Anyone else want to do one? Go ahead, Alex. For the one that Nisi just did, you could have also broken that up to 5 times 5 is 25, 5 times 5 is 25, 25 times 25 is 625, or you could have done 5 times 5 is 25, 25 times 5 is 125, 125 times 5 is 625. There's a bunch of different ways to do that. Thank you. Anyone else? Switch me and Sophia. You guys can take whichever one you want. Yes. And Kayla and 1, 2, 3, I think one more person. Thank you. Anyone want to do the last one? Alex, you can do it. Okay, Alex. This is only 2 of you now. Remember when there was 3 of you, so that was confusing.
Yes, that is true.
All of these are correct. 8, 125, 1, 32, 625, 16. I really like that Kayla used parentheses here. We'll talk about why I like that here in a second. Anyone want to take a guess as to what our next unit is on?
Decimals.
Exponents. So this is a really short unit, so I want you to look at your schedule. I need you to fix a couple things because I forgot about this when I made the schedule. March 3rd is election day, so you guys don't have school because most of the school buildings are being used for that. So everything else after that needs to be changed. So instead of Monday, Tuesday, 3, 2, 3, 3, it should be Monday, Wednesday, 3, 2, 3, 4. And then all the days after that are changed. Thursday, Friday, Monday, Tuesday, with the dates 3, 5, 3, 6, 3, 9, 3, 10. I did grade your tests. We'll talk about those a little later. Overall, most of you did very well. Most of the class did very well. There were minor things that we'll talk about later. And then if you didn't do so well, so just like before, if you got a D or an F on any of the objectives, you can come retake that before or after school. You'll have to do test corrections, turn in missing work, things like that. I also want to say a couple other things schedule-wise. So I already put the dates of when this test will be, which is the same date on your paper, except I need to change it because it should say 3, 9, 3, 10 on the board. That will be the last test that will go on this quarter. We'll test twice after that, the quarter test and the next unit after that. So I said that wrong. The quarter test is obviously going to go in this quarter. The next unit will test in this quarter, but it won't go on this marking period. It will go on the next one. And everything related to that next unit will go on the next marking period. Not really in this unit, but starting with the next we only have 3 units left after this. Radicals, 3.5. Radicals, factoring quadratics, and direct and inverse variation, but that's very, very short. So that's why I said 3.5. Those are all going to get covered before we take our SOL. At some point, we'll stop testing before the SOL and just focus on SOL review. Later today, you're going to get an SOL review packet, so you'll start doing those throughout. I do want you to keep this date in mind. I wrote it a couple weeks ago, but it will shortly be here. May 19th is our SOL date.
Right.
Do we have questions on anything scheduling, anything for this unit, testing, anything like that right now? Alright, find the page of your notes. That looks like this. I do want to say one other thing. The blue little review book you got, I won't ever check that, collect it. That will be extra practice for you whenever. So if you go through it, there will be things that we will cover in this Exponent unit that you can practice on throughout that book. So as we start to get into our exponents, we need to know a couple things. One, let me go back to the review. Anyone know what this number is called? There's a word for it. Not coefficient, not decimal. No. The base. So the number, the bigger number is your base. You could write this on your review or write it again on your notes. Making this the actual exponent or power. I'm just going to rewrite that up here. So we do need to know the difference between those two, because if we confuse them, we kind of confuse everything else. So this is saying if we have a negative base, so I'm just going to take 2, I'm going to make it negative, and I'm going to raise it to an even power. Let's say I choose 2. What is negative 2 squared? Is it? So think about this as negative 2 times negative 2. So it would be positive. So anytime we have and it doesn't matter the number I use for my base, anytime we have a negative base raised to a even power, as long as we're using our parentheses, we will get a positive number. If we didn't use parentheses, if you type this in your calculator, you're going to get negative 4. You could try that. The reason is in the calculator, instead of doing this, it's saying negative 1 times 2 times 2, which is not the same thing. So if we don't use parentheses, it changes our answer completely. We have to use parentheses. That's why when Kayla drew her parentheses, I really like that idea. Get in the habit of doing that, especially with negative bases. Positive bases, you don't really need it, but it's good practice. Right. Now let's change that. What if we had a negative base and we raise it to an odd power?
it'd be -2 times -2 times -2.
Well, will this end up being positive or negative? Negative. So no matter if you use parentheses or not, in this case, you'll get a negative answer. This would be -8, because here you have +4. If you don't use the parentheses, again, just like before, this would become -1 times 2 times 2 times 2. Even though we know this part is 8, it still becomes negative. So in this case, it doesn't really matter if you use parentheses or not, but I would still use parentheses just for good practice. Before we talk about these negative exponents, we'll get into that in a second. Let's do these. How would I write out 0 squared? I know that's the answer. How would I write it out? Which is 0. How would I write out 1 squared? 1 times 1, which is 1. How would I write out 2 squared? And 3 squared? So we know how positive exponents work. When we have negative exponents, weird things happen. So anytime we have a negative exponent, so this is really just this down here. It takes the base, changes it to its reciprocal, so remember that's whatever it was switched. Remember, all whole numbers are really over 1. So if I'm taking that base and I'm switching it, this is now 1 over 0. Something else interesting happens when you have a negative exponent. For whatever reason, let's call it math magic, your exponent becomes positive. And it gets moved to your denominator. Now, I'm going to come back to this one because this is a special case. Let's go to this one. 1 over 1 is really still just 1, but for all intensive purposes, I'm going to do this just like before. I have 1 over 1 squared. We know that 1 squared is what? 1. So in this case, nothing really changes. 1 to any exponent is still 1, whether that's positive or negative. That has not changed. It's our other numbers that kind of mess things up. If I take the reciprocal of 2, I now have 1/2. My exponent moves to my denominator. I know that 2 squared is what? 4, but it's now in my denominator. So anytime you have a negative exponent, you're taking your base, you're flipping it. You're taking your negative exponent, making it positive, and moving it to the denominator, and solving it from there. So if I did the same thing to 3 to the negative 2, it'd be 1/9. Another way you can think about this is taking 3 squared, which we know is 9, and taking the reciprocal of that, 1/9. Both of the methods work. You just have to be very on your math facts, multiplication facts. Let's go back to this 1 over 0. What is 0 squared? 0. What would this be? What's the reciprocal of 0? not 1, it's not 0. 1 over 0 or any number over 0 is non-existent. It's undefined. Not quite. Infinity just means you keep going. This is non-existent. There's a difference. What questions do we have on negative exponents right now? Now let's take it up a notch.
Oh, letters.
Now we have variables instead of letters. So we're going to do this exactly as we just did. A squared, if I wrote this out, would be what? A times A, which is still A squared. We don't know what A is. That's okay. We could keep going with these, but we know whenever we write these out, there's still going to be whatever this is here. It's not going to change. I'll do that just so you see it. Now, any number by itself, any variable by itself has an exponent 1. Sometimes that 1 will not be there. So if I just wrote d instead of d to the first, it would still mean d to the first. If we're thinking about this the same way we were thinking about our numbers with negative exponents, what would I do to this a to the negative 3? Put 1 over a and square it. So a to the negative 2 is now 1 over a squared. Same thing would work for all of these variables. I'm going to skip down to d. What would this one look like as a negative exponent, with a negative exponent? Just 1 over d. Though d to the first is not necessary. I want you to go ahead and do x to the negative 3rd and y to the negative 5th. What is x to the negative 3rd? 1 over x to the 3rd power. And then y to the negative 5th? 1 over y to the 5th power.
Since it's an odd number, wouldn't it be into a negative? Since they're both odd?
For the exponent?
Yeah, y and x. Wouldn't that be negative since they both have odd exponents?
So the odd exponent doesn't. Let me go back.
To this.
Our negative base, we don't have a negative base. So what we did at the beginning is different than what we're doing now. So no, it wouldn't be negative. But if I had negative y to the negative 5th, then yes, it would be negative.
Okay.
Or if I had negative a to negative 2, that would still be positive because I still have an even exponent. Okay, we're going to stop there and finish when we come back. Let's start with this one. 5b, all of that squared. Good.
So if I'm taking that and I'm squaring it, that would be the same thing as me writing 5b times 5b, right? I could also rearrange that because multiplication is commutative. I could say this is the same thing as 5 times 5 times b times b, right? Since multiplication is commutative. Well, 5 times 5 is 25. B times b is b
Squared.
squared. So every time you have variables and numbers being squared or being raised to some power, you're really doing it with both. So I did that, but I didn't need to. I could have just said, I need to square 5, I need to square b. And we would have got the same thing. Same thing applies to when you have negative exponents. Yes.
I was gonna say, why is the 5 negative 2 b2?
Oh, it wasn't. It's 5 squared. It just looks like that because that's part of the 5. Same thing for your negative exponents. I'm really taking both of these variables and applying negative 3 to them. But you cannot have negative exponents. That should be, whenever you see that light bulb should go off, that you still need to do something with this. So I can change both of these to be 1 over a to the third times 1 over b to the third. Taking the base, taking the reciprocal, taking the exponent, making it positive, but putting it in the denominator. Is there a way to combine these two? Sophia, 1 over 83 plus 83? Not plus. We're still multiplying. It would just be 83. So when you get negative exponents, you can separate them or do them separately, that's fine, but at the end they should all be as one fraction because we're multiplying. If you have positive exponents, you should have everything multiplied together. You don't need to put the dots in between because things next to one another are multiplying. They just need to be next to one another. Do we have questions on either of these two? I want you to go ahead and try these 4. I'll be walking around if you have questions. Alright, I'm going to start working these out, and then we'll go over each one. If you have questions, please ask. So for this first one, depending on how you do this, you could have done this a couple different ways. I could have rewrote this entire thing as 1 over 3a to the first. Seeing that this entire thing is being raised to the negative 1, so if I take my base and I flip it, and then raise it to that positive exponent, this would be 1 over 3a. Or, if you did what we did over here, and kind of put that exponent as both, that'd be 3 to the negative 1 times a to the negative 1, which would be 1 over 3 times 1 over a, and then combining them, you would still get 1 over 3a. So you could do either or, both still work. Questions on that one? For this one, same thing. So So I could take that same logic, I could say this is my entire base is being raised to a negative exponent. So if I put a 1 underneath it and I flip it, this is now 1 over 3a squared. And then I can make 2 or 3 squared, I can make a squared to get 1 over this. But because 3 squared is some number we can figure out, you can simplify that. Kind of make my 9's and a's look a little different. But you could have also taken negative 2, kind of made it the exponent for both. So I'd have 3 to the negative 2, a to the negative 2. Excuse me. I would change this base to become 1 over 3 squared multiplied to 1 over a squared. 3 squared is still 9. And then I'd still combine them to get 1 over 9a squared. So as I'm showing you both methods with these, you don't need to do both. You need to figure out which one you like better and do that. Stick with that. Questions on that? The next one wasn't that bad because you didn't have a negative exponent. So your answer should have been a squared b squared. Or if you took it and you separated it, AB times AB is the same thing as A times B times A times B. Or I can rearrange this to say A times A times B times B, which is still A squared B squared. And then in your last one, I could take my entire base, move it to my denominator, make my exponent positive. And I wasn't doing these with the other examples, but the expanding piece you can still do, even if you do it this way. And I could square both the 2 and the x. And that would give us 1 over 4x squared. Or I could do them individually and say 2 to the negative 2 times x to the negative 2, which would give me 1 over 2 squared times 1 over x squared. I would still need to simplify this because I know this is 4. And you'd get the same thing. If you were separating it as we did the AB, kind of in this step or in this step, it would look like this. And you would do the same things. Rewrite it, move things around. Notice that none of these answers are negative because our base wasn't negative. So don't confuse your negative bases with your negative exponents. Those are 2 different things. Questions on this? Flip this over to the back. Alright, when we talk about 0 exponents, you are also missing one of these rows. So go ahead and write this column in.
to give you some background. This is some random number I chose, and I did 2 to the third, 2 squared, 2 to the first. And then I wanted to show you what 2 to the 0 is. So when you put your calculator in, something weird happens. When you put this in your calculator, anytime you put any number to the 0 power, you get 0. You get 1, no matter what it is. But when I look at this pattern, each time I'm dividing by 2. So it kind of makes sense that I get 1. When I use 10 as my base, each time I'm dividing by 10. So again, it makes sense that I get 1 as an answer for that last one. Even when my base is negative, each time I'm dividing by -3. And I still get 1. So no matter whether your base is negative or positive, you get 1 when you put 0 in as the exponent. But when we get to our zeros, weird things happen. In your calculator, put in 0 to the 0 power. So if you are confused on how to do that, use your little caret, which is above the division sign. So 0 to the 0 power. What do you get? Did you get 0? You got error. Okay. So 0 to the 0 power, we got an error. We're going to talk about why here in a second. Let's go back to each of these. Or go back to this last one. So in our 0 patterns, we've been dividing by the same base, getting 1. So this should be true, right? Any base to 0 should be 1, but that's not what we got here. If it should be 1, but we got an error, because that's the equivalent of sorry, I was thinking of something else. I was also thinking about our negative exponents, because I know 0 to any power is also undefined. So this shouldn't have been 1 anyway. It should have been undefined regardless. And it can't be 1 or both, which is why you get, or it can't be 1 or the other. So it has to be undefined. So 0 isn't a weird case every time. For negative exponents and 0 exponents, you get undefined. Yeah. Yes. Okay. Now we're going to do some random examples. I have 8 to the 0 here. I don't know what 8 is, but what should the answer be? 1. Because it doesn't matter what 8 is, the answer is always 1. Every time you have a 0 exponent. What if I had, I'm going to make up some random thing. What would this be? It would still be 1. So as long as everything in the parentheses is being raised to the 0 power, it's still 1. But if I rewrite this and say maybe a to the 0, I started that off all the way wrong. whatever is inside your parentheses is still 1. Everything outside does not become 1. It is still there. Don't make it disappear. Do we have any questions on how negative or 0 exponents work? So for the rest of class, this is what I want you to work on. Yes, I want you to do all of them. Ask help if you need to, if you need it. It is homework if you don't finish it, but you have plenty of time to finish it. You also have, I don't know if it's this week or next week, I don't remember when I assigned it, one Khan Academy on 0 and negative exponents that you could do. If you finish these before class is over, I would go back into your blue book, do the problems in there so you have extra practice. Yes, I forgot what it was.